Okay, so I created a new application here. I'm calling it Files. And we're going to use this to go ahead and try some different types of storage information here. So let me first of all bring over a little note here. So this is a link to that page that I just showed you where it was talking about the different types of storage there. So the first thing we're going to do is just some real basic file I/O, just to be able to write some information out and read some information back in. So the first thing we're going to do is start off by creating some functions here. Let's go ahead and put it down here. I'm going to get rid of this UE that we've got there. We'll put something else there in a minute. And I'll just call it write files. Now this is one of those places where coroutines come in very, very handy. And let me see, I'm just gonna copy in my coroutine dependency, and we'll fix the, so let's see, this should be 101, and this should be 1521. I'm gonna go ahead and bring in the coroutines there, fix up that JUnit dependency and synchronize it. There we go, that all looks good now. And this write files is a suspend function. And one of the nice things about this is we can call this with context suspend function to ensure that we're on a certain dispatcher. The IO dispatcher is one that can handle blocking calls very nicely. It's optimized for that with the number of threads that it can run. I believe it's set up to have a pool of up to 64 threads. I'm trying to remember. It's either 64 or the number of threads that are native for the number of processors you have, whatever the maximum of that is. So it's going to set up that pool of threads behind the scenes. But what's really important here is that we're having this function define where it wants to run. And you can't do this in Java. In Java, when you start a thread or when you join a thread pool, you're doing that before you call something. So this is one of the big advantages of coroutines, is that you can tell it where something's going to run for the thing itself. Because we're going to be doing file I/O, we want to do this in the IO dispatcher. So let's start off pretty simple here. I'm going to say, let's give ourselves a subdirectory that we want to write to. And I'm going to use the file API from Java to do this. So I'm going to start off by saying I want to get my files directory, where I write my private files, into the internal storage. And I can do that just by using the filesdir property. Behind the scenes, that's calling get filesdir inside the activity to get that. And then I'm going to want to make the subdirectory, I'm going to call it my stuff. And this is an abstract file name, so it represents the directory. It doesn't actually create that directory. So we're going to need to create that directory. I can say subdir dot makeDirs. And there's a makedir and a makeDirs, so singular and plural. The singular one only creates the single directory. That assumes that the parent directory exists, and if it doesn't, it's going to fail. MakeDirs will double check that the parent exists, and if it doesn't, it'll recursively go up and create parent directory chain. So that should create the subdirectories there. Let's go ahead and create another file here inside that subdirectory. I'm going to call it sample1.txt. Again, file name, it hasn't actually created any type of file on the file system yet. So I'm going to write out some text to that. And Kotlin actually has a really nice helper function called write text, which can just take a block of text. Let's go ahead and copy this from my example I've been working on. So it'll take this block of text and write it out. The advantage to this is obviously you don't have to do a whole bunch of looping and anything like that. You just have one call. The disadvantage is you have to have the entire contents there at one shot. So if you're writing out a really small file, this is a great option. If you have a lot of stuff to write out, or you can't get all the data in one shot to write out, then you're going to want to use some other approaches I'll show in a minute. But this is a nice, simple one to start with. And what we're going to do is we're going to use this as our starting point to test out this application, just so you can kind of see where things end up on the file system. So let's say in our user interface, let's create a, whoops. And let's make, actually, I don't want him to be scrollable, so that'll be good there. So make him fill max width. And let's put a couple buttons up at the top of this guy. And let's say fill max width on him. Actually, we'll make him be fill max size. So in this one, I'm just going to have a couple buttons. Let me make a little helper function for buttons up here. Let's just call it my button. And we're going to have some text, which is a string, and an on click. Which is just going to be a little lambda there. What I'd also like to do, this button, what I'd like to do is when it's clicked, I'd like it to kick off a coroutine so that we can do things in the background. So I'm going to pull that, first of all, inside of my set content call so I can create my coroutine scope. And I'm going to make this clickable be a suspend function. So that means that inside this clickable, we could actually call other suspend functions. And let's put in an on click here is going to be scope.launch. So we're going to start off a coroutine and then actually call the real on click, which is our suspend function there. I'm also going to pass in a modifier here. Let's pass in padding. There we go. So that should be pretty good there, I think. Except I didn't put any text inside there. Let's put the text equals text. So this little helper function, sometimes you're going to notice when you're writing your code that there's going to be a lot of similarity in things that you're writing. And we're going to have a whole bunch of buttons, and they're all going to look exactly like this. So I just wanted to shorten that up so I don't have to keep typing 3 million lines every single time. So let's put in a my button here with text equals write files. And we're going to have it do something on the click. So have him call write files, just like that. Now, because the entire body of that lambda is just that one expression, and the signature of this guy is the same as the signature of the lambda, I can just do this and use a functional reference. And that just shortens things up a little bit there. And what does he not like about the fill max size here? Oh, I just didn't import it. So there's our write files. Let me go ahead and do a read files as well while I'm at it. And let's define a little read files function. Whoops. Just like that. And so now we should have a little simple user interface that can write the files out. Let's try running this and see what ends up happening. I have to resize this emulator a little bit. Probably make that a little bit bigger. For some reason, I can't resize it when it's inside the Zoom window. That's a little better. So now I got my read files and my write files. I'm going to hit the write files button. Doesn't look like anything interesting happened, but let's take a look on the emulator and see what's going on. what I'd like to do is go to the View tool windows, Device File Explorer, and that'll usually pop it up over here on the right edge at the bottom. This is going to show you the file system, including internal files on this device. Now, the internal directory structure that holds where the files are written for application-specific files is underneath /data, and then the application ID. So if I come down here and take a look at Stanchfield Scott files, you'll see that my files 1 was my prep project. Underneath here, we see there's a cache directory, a code cache directory, and a files directory. As soon as you write files, it creates that files directory for us. In this case, I created that subdirectory, my stuff, and underneath there is sample.txt. If I double click on him, boom, it's got my data in it. So it's successfully written to that directory. Now, if instead of looking in this Explorer, if you wanted to actually look at it from a command line, we should be able to do an Adb Shell. Let me make sure I don't have a tablet plugged in. If you have more than one thing plugged in, like once in a while I'll have an emulator running and I'll have a tablet plugged in, you can actually pass in -E to explicitly say, I want to talk to the emulator as opposed to the device that's plugged in. If you have more than one emulator, then you have to pass an ID for the emulator in as well. But since I only have the emulator running, I can just do an Adb Shell. This now takes me onto that tablet where I can take a look at the file system. And you'll notice the file system is the same as what I'm seeing over here. If I want to go into that data directory, if I try just going to data, and try to go into Stanchfield Scott files, it says permission denied. That directory is protected from anybody except for the specific application. You can convert your current user ID into the application user ID if you're running the application in debug mode. So right now we're running it in debug, and by that I mean over here under build variants, the active build variant is debug and not release. If it's release, you won't be able to do this. But this is useful for debugs. You can actually go in and take a look at things. So in order to assume control of the application's user ID, I can say run as Stanchfield Scott files. So you use the application ID as the user there. And now it puts us right into that application directory. There you can see our cache, code, cache, and files. There's our files directory with our my stuff directory. And then I can say cat sample1.txt, and boom, there's my results there. So we've successfully written out to the application-specific directory. Now I want to do a couple other examples to that same place, just so we can see how the file I/O itself actually works. So we're going to add in some other examples here. So let's do a file2 subdir, and we'll call it sample2.txt. And we're going to write it out a little bit differently. What I want to do is I'm going to create a writer for this and do a use on it. Notice with this write text, I didn't do a use. That's because behind the scenes, the write text does that for you. He opens the file, does a use on it, and then writes the data out. This time, I'm going to do that a little bit more explicitly. I'm going to say file2, create a writer for it using the default character encoding, and then do a use. And then inside here, I can write some stuff out. So let's go ahead and do a 1 to 10 for each. And let's call this a writer here. Writer.write. And I will write out the, oops, actually I wanted to do a, toString. So I get the wrong piece of code for a second there. So what we're going to do is we're going to convert that number into a string and then write it out to the file. So that'll be our second example. Let's have our third example be a little bit different than that. Call this sample3.txt. And this time, instead of a writer, I'm going to use a print writer. which is going to give us println functionality so we can automatically do new lines. I could up here, of course, had said, write a new line, kind of like that, just be explicit that I'm writing out a new line character, or character as opposed to the whole string. And that would give me separation. I'm not going to do that just so you can see. I guess the right is going to let me do the character. Oh, no, that should be a single. Oh, right takes an integer instead of that. So I could do something gross like that. Don't want to do that right now. So I'm just going to write all of these side by side. This one here, I'm going to do a println instead of a write. And the println automatically calls toString and whatever the argument is, and then writes it out, followed by a new line character. So that'll be kind of nice. Let's take a look at a fourth example. Call it sample 4. And this one, actually, I'm going to hold off on that one for the moment. We'll come back to him. Let's try writing this out. Run the application. And let's do our write files. Take a look at our Explorer. And we should see, I'm going to right click on this and say synchronize. And boom, now it's showing all of those files inside there. So there's sample 2. The 1 through 10 are just written right out. Then this one, it writes the 1 through 10 out like that. So let's go ahead and write some code to read this information in. And to do that, I want some place to put it. Let's do a private text by mutable state of, var, mutable state of, there he is. And we'll just say he's got nothing in there to start with. Again, I need to import the get value and set value so that he can act on behalf of this variable. Anytime the getter is called, it'll call the getter on this. Anytime the setter is called, it's going to call the setter on this. Delegation is wonderful. So we're going to take this text and print it out on the user interface. So what I'm doing here is anytime the text changes, I'm going to re-render this text. So it's going to recompose it. And I'm going to have this fill up whatever the maximum width is. And this weight says inside this column, anybody who has a weight, we're going to divide up the remaining space based on that weight. So this row would be laid out. This guy's going to take up all the rest of the space on the screen. Put some padding around them, but notice how I have padding in 2 spots here. This is a little example I wanted to show you. What I'm doing is I'm drawing a rounded border. On the outside of that rounded border, I've got 8 dp worth of space, separating it out. On the inside of the border, I've got another 8 dp. The order of these things matters. So if you want to do something like, in the old Android model, they had the concept of margin and padding were 2 separate things. And there were a couple other wrinkles inside there. This is so much simpler because you can just have your margin around you, just specify a padding. And then the padding on the inside, which is just space inside the component, it's just padding again. And then I'm going to make this scrollable just in case there's some content in it that's a little bit too big. So there's a nice little text there. We can print things out. Let's do this read. So we're going to do the same kind of thing we did before. I'm going to create a subdirectory. So we start with our files dir. So that's where our stuff is on internal storage. And my stuff is the directory that we're dealing with. I'm going to say file1 equals file subdir sample1.txt. And then I'm just going to read in that entire file and just blast it out. So I'm going to say file1 dot read text, which is the opposite of that write text that we got from Kotlin there. And I'm going to say text equals that. Now, in order to make this a little more obvious what's going on where, I'm going to go ahead and say sample1.text, new line, and then we'll put him as a variable there. So this should print out sample1.text and then the contents right underneath it. I'm going to set up this read files function to read all of these files and blast them out to the text. So I want to put a little delay in between each one. Let's say 1500, because we're in a suspend function here, so we can do that. And let's do something similar with file 2. And what I'm going to do for file 2 is we're going to read in chunks of data at a time. So I'm going to implement my own buffering to do this. I'm not going to use any type of special buffering here. We'll see special buffering in a minute, just so you can see how it's a little bit simpler to do. And to do this, I'm going to say val string builder equals string builder. This is a guy in Java that gives us a place, and there's a Kotlin version of it as well, that gives us a place to collect stuff to build up a longer string. And then I'm going to want to open up that file. So file 2, reader. So I'm calling reader because I want it to read characters. Use to make sure that it's going to be closed. I'll create a buffer. And I'll just make this be 1024, so it'll be a 1K buffer. I'm going to have a variable to keep track of how many characters were read. And as the way that I'm going to do this is anytime you make a read call, it's going to tell you how many characters were read. If that doesn't match 1024, I'm going to go ahead and quit my loop. That's not exactly the right way to do things for networking, but for this example, it'll work really well. So I'm going to say while count equals 1024. So as long as I've read 1024 characters, then I'm going to say count equals reader, which I need to define up here, dot read into that buffer. So it's going to try to read up to 1024 characters. Then I'm going to say string builder dot append buffer, and I need to say start and count, just in case I haven't filled that buffer completely. So this should end up, that needs to be equal. This should end up reading things in. Now let's take a look at this read that it's giving us a warning on. When I float over it, it's going to say inappropriate blocking method call. And what this means is there's a lint check inside Android Studio that's not super bright. They kind of set it so that it's going to have more false positives and not have false negatives. Anytime it sees a blocking call, and at this point, the read is actually going to block this coroutine, as opposed to normally with a coroutine, you call a suspend function, and the coroutine can just suspend and let somebody else use that thread. Well, in this case, dispatchers.io is designed to do blocking IO. So what we can do here is just say, no, this isn't really an issue. I'm going to come down here and say, mark that as blocking method in non-blocking context. It's perfectly fine here. We're running inside dispatchers.io. That's okay. Now be careful on when you use this. If you use other dispatchers, you never want to suppress that. Other dispatchers should not have any blocking. But the IO one, it's fine if you're going to have a blocking IO call like that. So that should read him in. Let's go ahead and say text equals sample2.text, new line, and then we will say string builder, which will convert that string builder into a string and print it out as the text. Let's do another delay down here. So that text will stay on the screen for a moment. So that's a second way, and we're doing our own manual buffering at that point. Now for these, I'm going to do the next two files, just reading them in using a buffered reader. So since I want to do two files here, I'm going to say for file 3 and file 4, for each, let's say val file equals file subdir sample $it.text. That'll be our file name for the file we want to read in. I'm going to reuse that same string builder. Just going to clear it. And then I'm going to say file.bufferedReader, which is going to set up something that does the buffering for us. So he's going to keep track of that. I think the default on him is 8K. Let's see, default buffer size. Yeah, the default is 8K on him. So we're going to take that buffered reader and we're going to use it. And I'll say reader like that. And what I want to do inside here is read in lines at a time and put them into that string builder. So the thing that I'm actually reading from the buffer is an entire line. So if that buffer didn't have enough information to get to the next line, he'll just read the next chunk from the file to find that next line, which is kind of nice. And so now I can say count equals reader. Oh, that's not what I want to do here. I want to do lines. So let's say while true. And then inside here, val line equals reader dot read line. And if line is null, we're going to break. So we're all done. Else, we're going to append the line. I should say append line, which automatically does our new line there, to our actual text there. So this will just build up that string, and then we can just append it the same way we did up here. So we sample 3 with the string builder. And let's see, where did the delay go? I don't have a delay in between there. Let's do a delay there. And we'll put a delay after each file here. Just like that. Okay, so I think that's all we want to do for the moment. Let's see if now we can write out these files and read them back in and have them be displayed inside the user interface. Ooh, look at our nice rounded box for our text. Nifty, eh? So let's write the files out. I'm gonna hit read files, and now it's gonna show each of the files in turn with a little delay in between each. Okay, so something went wrong there. Let's take a look at what's happening here. Sample 4, no such file or directory inside there. So did I actually write that one out? Where's my write? Oh, I didn't actually write the fourth one out yet. So let's just change this to 3 to 3 for the moment. Make sure that's going to work. Write files, read files. And there's sample 3, and there we go. So now we're able to read and write files from that private directory. Okay, so the next thing that we're going to do is I want to write a filter that's going to convert all of the input to uppercase as we're going in here. So I'm just going to come down to the bottom of the file here. Actually, let me just put that in another file. I'm going to try to break this example up a little bit better than I did earlier. Let's come in here and we're going to say new uppercase, hello, uppercase writer. And this guy is going to be a filter writer, which is a special type of writer who wraps another writer. Now, one of the things that happens when you extend a Java API or when you use Java APIs, Kotlin can't necessarily tell if something's nullable or not. Sometimes the Kotlin API is marked up with annotations telling you when things are nullable. In this case, this one obviously didn't have his argument. If we take a look at him, his argument just says writer out. So there's no way to tell if the designer of this API meant for that to be nullable or not. So Kotlin, when it converts this, has to assume it's nullable. Now, in this particular case, I'm going to say no. I'm not going to allow this to be used on something that's null. And if we actually take a look at this API here, you're going to see that this really should not be nullable. And it says throws null pointer exception if out is null. Well, you'll see inside this function, it doesn't. This is actually a bad comment. It's going to throw the null pointer exception down here when we actually use it. So in this case, this should have been marked as not null. So I'm going to explicitly mark that as not null there. And we have 3 write functions. I'm just going to copy this stuff in here. They're actually going to do our work. So the filter writer is going to use these 3 and then forward it to other functions. So what I'm doing, if we're writing just a single character, which comes in as an integer, I'm going to convert that integer to a character and uppercase it, and then call superWrite for a character. So I'm just converting this. This is a decorator, because the API is the same as my superclass, the filter writer. So the API is the same as this writer here, but I'm changing what happens to the parameters in this case. So usually what a decorator does is it either just passes things through, or it'll tweak parameters going through, or it'll tweak results coming out. But the API is the same on the thing that you're wrapping. So we can use our uppercase writer to wrap any other writer and tweak the behavior. So this is a decorator pattern. This guy here, this write function, I'm just going to convert the buffer to a string and call my other write function here, so I don't have to repeat the same kind of logic. So this one here, when I write a string out with a given offset and length, I'm going to uppercase that string, which creates a new string, and then use that uppercase string offset length in the superclass. And that's all I need here to make this work. I can now use this when I'm setting up my file IO. So if I come up to this guy here, that's my write files, that's the right one. I'm going to write this guy. And so now I'm going to say file 4. Let's do a buffered writer on him. But we're going to surround that with my uppercase writer. So this is how you can apply those filters. We're wrapping one of the streams inside of this filter that I've created. And so now inside here, I'm going to write out some data. Actually, let's just write something a little different. Instead of doing this, let's say writer.write. Put in some, this is a sample file, another line, yet another line, something like that. So we're going to write that out. And if this works like I expect it to, it should uppercase the data when it's writing it out. Once again, we have the same issue about the non-blocking IO. So I'm just going to flag him. Oh, what did that do? Just wanted for the statement. There we go. So whenever you're doing these suppresses, keep them as close to the actual source of the problem as possible. And usually I like to put a comment here saying blocking IO is okay in dispatchers.io, something like that. Something to describe why you're disabling that warning there. Because sometimes warnings are good. Sometimes in this case, this one was a little too broad. So we just want to turn that off there. So that should write him out. And now I can come up here and change this guy to the 4 again. And when I run him, let's first of all write. So it's going to write all the data out. When we read them in, there's our sample 1, 2, 3, and I think I got one too many delays somewhere. Oh, I should say sample 4. And I have a delay there. I should delay before him, delay after him, delay after him. Oh, I see. It didn't update this because I put this should be inside the loop. We actually should be updating that each time and then pausing for the next one. So now that'll work right. So I'm going to hit read files because the files are still there on the disk. And I have sample 4 listed twice there. Let's make this be $it. And just double check, make sure that's going to be okay. 1, 2, 3, and 4. There we go. So that's actually doing exactly the right thing now.